So to start off, my name is Jason Peipelman. I'm with IBM. I work in the areas of design for IBM, so it will be an interesting conversation to talk to you guys not only about the technology that we're building on top of and how we're integrating our technologies, but also, you know, what we've gotten as far as user input, trying to ensure that we have user-directed roadmaps that satisfy our actual users' problems as we go forward. I'll be talking about IBM Deep Archive as we go through here. That will be an active archive. As you've seen from some of the speakers here, including the keynotes, active archive is a hot discussion. If you were here for the previous presenter talking about AI, it's also a very active discussion as far as AI goes and what they need. What he called cold storage, we call active archive. So as we go through here, it's great to hear about other people talking about new technologies as far as archival goes. They're talking about how to make reads and writes faster, how to make media last longer, how to handle, reduce the number of migrations. This is all really valid stuff. IBM has, over 50 years in archival storage. We've been there, we've done that, we've talked about those issues in the past. And I will talk about them as I go through these slides. But something to note as we go through is really identifying the key inhibitors to what the inhibitors clients have in adopting these active archives, right? What's preventing everyone in the field, every data center in the world, from having an archival component inside of it and having it be ubiquitous to all of them? So as I go through here, some of these slides are from the marketing team. I know you guys are developers, so feel free to ask any questions as I go through. I'll stay focused on the technology rather than making this sound like a sales pitch, because it won't be. So just a level set on the world in which we're living in, which others have done prior to my presentation here. Unstructured data growth is huge. We're trying to deal with that. As we go through, 43% of IT decision makers feel that their IT infrastructure won't handle future demands. When they're talking about these demands, they're talking about power and space requirements inside of their data centers, SAN networking, just their general infrastructure they have currently installed, and their plans for upgrading it. But they're also talking about their administration. They're also talking about the skills required to manage these devices. As we move forward, I think you guys have all seen the skill level of storage administrators in the field. Most of the highly skilled storage administrators are in their 50s to 60s. They're getting close to retirement. The new people that are getting hired on aren't necessarily as well trained or as well versed in the intricacies of the storage. They expect to manage them as consumer devices, not as technology. So as we move forward, we have to react to that and deal with that. The unstructured data growth has caused us to require active archive. Now, the reason people aren't talking about, hey, we need some really cold storage, right? We need some storage that's stored in a vault somewhere off-site. They don't talk about that much anymore. People need an active archive. Active archive versus having to call your data up, perhaps having them deliver the tapes back to your data center and load them in, or anything like that. They want to be able to access their data without having to go through a data center administrator or somebody like that to get access to their data, whether it's through security or through just operations to get to their data. So this bottom tier on the left here, that cloud service tier where they're having to go fetch it and having to go through a process to get it, people want to move into the more archival long-term, the active archive tier, that third tier. They do not want to see their data written once and read never. There is use cases for that, and there is capability to do that, but what we're talking about here is what AI needs enablement for, which is the active archive and what our customers are asking for. So talking about that, what solutions do they have today? Many people are using cloud to try to enable this active archive. Big inhibitors of that, of course, are cost, and particularly unexpected costs, including data egress fees. You could hear plenty of horror stories from clients about storing their data in the cloud and then somehow making it accidentally accessible to via a website someplace. People click on that enough to where they're charged millions of dollars the next quarter and they weren't expecting it. So these unexpected costs, you can charge what you're going to charge, but if they don't know how to plan for their costs, customers get very nervous. And the other point, of course, is security. So those kind of match as far as our surveys and user research goes. Both cost, including unexpected cost, and security concerns. The fact that their data is not behind their own firewall, they can't institute their own security audit mechanisms to control their security access. So, like I said before, one of the things we investigated last year was really a discussion with our clients as well as our potential clients, many people from the field. A large statistically significant survey was done trying to discover what people want in an active archive. It's really the question of, if active archive is so important to you guys, why isn't it ubiquitous in your data centers today? So these 7 points came up over and over again in our discussions and in our quantitative and qualitative data. Integration, having standard integration into their environments. Many customers are using, like I said, cloud technology today. They're focused on cloud. They want to be able to plug in any solution as though it was a cloud solution. Cost, we've covered that before, particularly in unexpected costs. If all storage technology cost the same amount, we wouldn't be talking about archive, right? Everyone would just buy the standard SSDs at the same price and we'd all use that. So the reason archive storage is here is because of cost. Ease of use, like I said, the data center administrators are becoming less trained, so having somebody be capable of running the system without necessarily having knowledge of the technology inside of the system. That means having a black box, which is a self-contained solution. So it's a simple set of options that customers no longer want a set of knobs and switches and a giant control panel in order to tweak every variable of how the system behaves. They want the experts to do that. IBM, like I said, has 50 years of experience, over 50 years of experience in dealing with technology like this. So when we talk about knowing how the server should interact with the archival storage, we want to take that knowledge and make it programmatically accessible by the users. Of course, resiliency, making sure data protection is prioritized over data access. One of the responses we get a lot from our clients as far as active archive goes is that they want to make sure that the data once written is always there. It's not necessarily as important, which was surprising to us, that the data always be accessible at all times, meaning data accessibility, they can lose access every once in a while, but as long as the data is there and they can get access to it, that's good. And of course, that access needs to be pretty continuous, and any downtimes need to be very short and manageable. Data security and sustainability, both of these come up a lot. Sustainability, particularly in the area of when we're dealing with Europe, they need to reduce carbon footprints. They need to reduce power consumption. They need to find a way to store data at a lower cost. So that brings us into our solution that I'm going to be talking to you guys about and breaking down and going inside of. IBM Deep Archive is an easy to use, easy to integrate solution. It is a single appliance. It is a 19-inch rack with up to 27 petabytes of capacity. So you can compare that to other technologies discussed during this week, other archival technologies discussed. 4.6 terabytes per hour throughput, that's in our base model. It's up to 4.6 terabytes per hour. Reducing the cost of your cold storage by up to 80%. So cost savings was a very large focus of what we're doing here, and ensuring that the cost savings that you get from IBM is even greater than that of other solutions as well. As you look at other solutions that are getting venture capital funding or they're looking at new technologies, this is where you start to get some of the differentiation. The capacity in per footprint, the technology that's known and how it works, the ability to have a reduced cost, and those are the areas which you really start to see separation in the different technologies. And of course, this is a black box appliance, so as far as customers are concerned, we call it a giant USB stick. It's going to be connected to their environment via Ethernet cables and power cables. That's it. They're not dealing with the SAN environment. They're not dealing with anything else that's going on inside of it. Customers who have an S3 only environment can just plug this into their environment and run it. So as you can see, it's a different conversation than, hey, what technology is inside of this system enabling what it's going to be doing, to how is a customer going to be using this system? How do we make it as easy to use and easy to operate as possible? All right. And if you have any questions, feel free to ask as I go through, all right? All right, just breaking down those high-level benefits that we're trying to deliver to our clients, cost benefits. Standard interface, when I talk about a standard interface plugging into their S3 interface, I'm talking about S3 Glacier Flexible Retrieval storage class. So if you're familiar with S3, this is the storage class we support. We do not consider this system to be a replacement for your S3 infrastructure or an all-encompassing, all-in-one solution to your infrastructure. It is a component of your S3 environment. It is the archival component of your S3 environment. So when you're sending data here, this is the component that stores the S3 Glacier Flexible Retrieval data. Users who use this need no specialized knowledge of the underlying architecture that we have inside of this. It's installed in less than a day, and no tuning is required. It is plug and play. The black box solution allows complete encapsulation of the fiber channel or SAS interfaces that are inside, so you never need to worry about that. And our storage expert care, so this is a system that's completely serviced by IBM. So when you install it, you do not need to worry about servicing the system at all. It will be completely serviced by IBM. Again, sustainability for our object storage. Energy consumption is reduced by 97% over hard drives and 85% lower carbon footprint than compatible hard drive solutions. All right, so let's talk about what's in the box. And you've heard me kind of allude to this. This is a tape solution. So I will be talking to you about the Diamondback tape library that's inside of this box. I'll also be talking to you about what that means as far as this being a tape solution, and talking about some of the discussion items of other archival solutions around tape and its drawbacks and how we're trying to address those with this product as well. So to start with, this comes all in a single 19-inch rack. There's no external servers required, no external connections required at all, besides connecting the Ethernet and the power. A control node is installed in the top rack there. We will have up to 2 control nodes in the future, along with a switch. Today, we offer a configuration of 4 LTO9 tape drives. This will be expandable up to 14 in the future. Tape cartridges up to 1,500 tape cartridges can be installed around that, giving 27 petabytes of raw storage to the user in a 19-inch rack. This all delivers at 4.6 terabytes per hour. Yeah, do you have a question?
But you can, because you're IBM, you can actually compress that about to 3x, correct?
Yes, yes. We have inline compression at line speed, and we have inline encryption at line speed as well when the data is written. Correct. Good question. And this is all at around 23 watts per petabyte. So feel free to compare those. So this is used in deep archives, air gap, second or third copies, regulatory compliance. We have users who use this for cybersecurity. They want to back up their entire infrastructure every week, and they want to do that and they want to keep it for up to a year to 2 years. This is the kind of appliance you would need to do that. When I'm talking about this, keep in mind that we're talking about the tape library itself. So I get a lot of questions about the tape library when I'm saying, hey, it's tape. And everyone goes, by the time we get here, it's an S3 archival appliance. That's great. Here's how it works. Here's all the stats. That's great. Those are the stats we're looking for. By the way, it's tape inside of this thing. Oh, tape? I heard tape's bad. That's what we get, right? After they've already agreed to all of the statistics. It's like, that's fine. Let's talk about it. So do I have to take the tapes out? No. There's been, over the years, a conversion of customers who remove media from their libraries and those who keep it in. At this point, because of the amount of storage in one of these things, the media is designed to be kept inside of the system itself. This Diamondback tape library was GA'd in June of last year. It was originally designed for our hyperscalers. It has a lot of mechanisms to help our hyperscalers install this at scale. It is also used by other clients besides our hyperscalers because it's simple. It's not, we like to say, this is not your your father's tape library. This is new hardware, new configurations, really minimizing the amount of hardware complexity inside of the system, and using the lessons learned we have of how to move media within a library. There could be lots of cute ways of doing it. We've tried lots of cute ways of moving media between libraries. We've tried shuttles, we've tried rovers, we've tried switching robots, we've tried a lot of stuff. The answer is keep it simple. You want these to be repeatable, you want the solution to be scale out, and you want to make sure it's as easy to service as possible. So this keeps the cost to a minimum, this keeps the number of moving parts to a minimum, this keeps everything, reliability as high as possible as well. It also allows us to do fast deployment. So installation of the Diamondback tape library and the Deep Archive system that it's based off of can be done in less than an hour. So this is to match the installation server time that our hyperscalers require. There's preloaded media in this thing, so when it comes delivered with all the cartridges in there. If you've heard horror stories about, hey, I've tried to set up my multi-frame library and it's taken me a week to do it and then 2 weeks to load the media afterwards, again, this is done in less than an hour, and when I say that, that means an hour until you can do I/O to the system. It's a storage pod design. There's no regular media removal, as we've talked about before. Increased data density and energy savings. This uses less energy and is more dense. The reason we can fit 1,500 cartridges in there is because every single one of those storage slots is a 10 deep storage slot. So it holds 10 cartridges itself. You can see on the top, that's where we store our tape drives. It holds 14 tape drives. And then there's one I/O station, which holds around 10 drives. So you can pull drives out for maintenance. This is in case a drive, I'm sorry, this is so you can pull cartridges out for maintenance in case a cartridge is at the end of its life, or you need to replace cleaning cartridges, which is extremely rare, if never, for many of our systems. The air gap use cases we have. So you can ensure that you can logically take your cartridges offline so they cannot physically be read by hosts, right? So part of the natural air gap that you've heard from most of the solutions here discussing archival solutions, their air gap comes from the drive being physically separate from the media that it's reading, right? So that's the main air gap part of it. But it also includes ensuring that there's protections in code and in the system itself to control which media is made available to be mounted at all within those, and which media is reserved to be kept isolated from the rest of the system. So as we move forward, we're going to look at ensuring that the S3 object lock capability is integrated with our air gap technology so that when you do use the S3 object lock, that'll ensure that the air gap is also enforced as well. Yeah.
So this is using the LTO9, so that's an 18 terabyte native, but
that's correct.
IBM also announced their own enterprise tape at 50 terabytes.
Mm-hmm.
Is there anything you can do with that?
So currently, the Diamondback tape library is an LTO-only system. It does not support the enterprise tape cartridges, and that is done for a marketing reason. So it's done because there is more demand currently for LTO than there is for the enterprise libraries. So, good question, yeah. So if there ever is, we have designs to pivot around that. If there's ever input from our customer base that that is required, then by all means, we can look into that.
You could easily implement them in this design structure, obviously. It's almost like plug and play.
Yeah, it's
The LTO drive, the bigger offset.
mechanical engineering work and firmware work. You got it. Everything's possible with enough coders, right? Yeah.
You mentioned you have kind of magazine with 10 slots.
Mhm.
I cannot use each one individually.
Each one is what?
Individually, I do not have to load 10 tapes.
Correct. So the robotic accessor that we have in there has two grippers. So it's able to grab two different tapes at a time. So if it needs to get to a cartridge that's in a lower tiered slot within the system, it will shuffle the media and it will get to the media that way. Our average load time, including shuffling media and everything else, just averaged over a very long period of time with random access, is around 15 seconds to grab a cartridge and load it into the drive. And then the nominal time to get that cartridge loaded, spun up, and ready to read and write data at the correct location is around 17 seconds. Yes? Yes, a Pez dispenser, that's exactly. Yeah. Mm-hmm, yeah. Yeah, you're asking about what is like the minimum maximum load times that we could possibly have in there. It is very fast. So I don't have the numbers on me, but I've stood in front of the system and watched it do it. So it's very much like click, 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 for each shuffle. So it's not too much deviation between the 15 seconds that I stated between the maximum time and the minimum time. I would say 5 to 10 seconds on either side, you know. But it's very close. We also ensure that the most frequently accessed cartridges are kept near the front in higher tiers, as expected. Yeah. Yeah, good questions. I figured I'd leave it on this slide a little while for the tape slide, because I figured you had basic tape questions as well as deep archive questions. So, great. Yeah, some of the other questions I get, you know, are you running into the same cost capacity plateau that hard drives are running into, right? We heard a lot about HAMR technology here, about hard drive technologies improving, which is fantastic. Our aerial capacity of our cartridges is much greater than a disk. You think of a disk, that's how much area you have to deal with. You think of a tape cartridge, it's, you know, you measure it in meters by meters of capacity, because even though it's a 1-inch wide media, it's spooled many meters of media, right? So we have a lot of aerial density to work with. We are not running up into any of the aerial density problems that hard drives are having, and the way I've heard it discussed by our research team is we'll all be retired before we ever run into that problem. So everyone in this room will be. So don't have to worry about that. So we also heard a lot about, you know, how long does the data last? A lot of the technology that was discussed here is, you know, can we make the media last for hundreds of years, which is a great question. I'm really glad we're looking into that technology. Tape media is 11 nines of data durability. Most of our customers write single copies of data to single tapes, and they trust that. So they have a single robot with a single copy to a single tape. With 11 nines of data durability, and our tapes are rated according to LTO consortium up to 20 years of storage time. This is an extremely reliable media. I don't know if you guys remember, but in the Challenger crash, when the space shuttle blew up, there was tape media in that. We were able to recover data from that tape. So this is, yeah. if you've ever heard that story before, that's a good one. So yeah, it's a very reliable media, very, you know, world-tested way to store data. All right. The last one is migrating to new technologies. So I just wanted to hit on that one too, since that was brought up a lot during this week from other technologies. What we're doing with Deep Archive is to ensure this is a black box solution, which you're not going to be moving media back and forth from. It is designed to be LTO9. You buy one of these, you're buying an LTO9 Deep Archive system. If 5 years from now you need to expand your capacity, you can buy an LTO10 or 11 or whatever we're on, right? You can buy the next level of technology in a box next to it. The way most of our customers do this with the scale out options is just put the new box next to the old box. Continue upgrading your technology, continue expanding your environment with the new technology, but not necessarily sunsetting the technology that's there. So we expect around 10-year life cycles on these. So that's tape has very long life cycles inside of data centers. Cool. Yes.
I got a question. I guess it's more about marketing.
Mm-hmm.
I was involved in the launch of this last year, and so many potential customers are just kicking the can down the road. I've heard that a lot from the LTO folks. I know I got to move to tape. I know I got an energy problem. I know I've got a capacity problem. I know I've got a TCO problem.
Mm-hmm.
But like one of my favorite definitions of the enterprise is if it is not necessary to change, it is necessary not to change. I know I got to do it, but I don't got to do it this year. It's going to be next year, or the next year, or the next. That's been very, very frustrating, I know, for all LTO vendors, because the knowledge is there, and these are not dumb systems administrators. Incredibly intelligent about what they will need in the future. Does this box and this solution get you any further to taking over that portion of the deep but accessible archive that is currently serviced by hard disk drives? I mean,
Good question.
Portion, like, maybe 5 to 10% is serviced by tape at this point. Vast majority still on disk. Do you see any migration away from that with this box? And I guess I'm asking, how well is it sold, and is it getting you into new environments?
Right. I'll answer the new environments part first. That was the discussion, and what I was trying to lead with as well is what is preventing us from the customers who know they need this. They know they need the TCO savings, they know they need the space savings, they know they need the power savings. What's stopping us from being ubiquitous in every data center? And the answers we get a lot from clients is, if I need to install a bunch of hard drives, a hard drive archive, I can do that, and there's technology already existing in my data center to do that. If I don't have tape and I want to install tape in my environment, I will have to figure out what additional technologies, library managers, extra software, education for my team on how to use tape in order to integrate tape into my environment. Therefore, the burden of trying to get tape into your environment to solve that problem is higher, and any burden like that is going to prevent adoption.
But you sort of answered all those objections by virtue of this design.
With the Deep Archive that was GA announced a month and a half ago, yes, we are trying to address those objections directly. We're not necessarily hearing people say, hey, we need our media to last longer. We need better random access time. The mount times are around 30 seconds, as I said before, to get your data in there. They're not saying, hey, I can get to my data within 30 seconds, but it would be nice if I got to it within 15. It's like, if there's a delay, if there's a multi-second delay, there's a multi-second delay. The difference between 15 seconds and 30 seconds isn't necessarily going to change their minds there, right? They're really saying, it's hard for me to integrate this new technology into my data center because of the education, the fact that it doesn't hook up to my existing infrastructure. So that's what we're trying to solve.
No, if it's an S3 infrastructure, you're hooking up to the existing infrastructure.
Yep.
Wow, I got out
Yeah. So the last thing I want to say about this is serviceability of this. There's QR codes within the doors of these things. If anything goes wrong, you can scan the QR code, you get a video of how to replace the part. It's all toolless replacement. You can do it just by twisting knobs and swapping out parts within 5 seconds. So it is super simple to replace any of the FRUs in this system as well. So, like I said, we've designed this as the next generation tape library to solve all of our existing problems that we found over the years. So, and then Deep Archive solves the integration problem, which is to make the system easier to integrate. This is more for clients. When they're going to purchase it, they have different capacity options. They can get up to a half-loaded box with 14 petabytes of media, or up to a maximum of 27 petabytes, depending on which license they buy. It's one of the few license questions they have to answer. They pretty much just say, how many drives do I want? How many cartridges do I want? Capacity, number of access points, and throughput. That's pretty much it, right? Back to basics. When we're talking about the integration, which is a big pain point into adopting tape, this is what it will look like in the future with Deep Archive. You can see this has 2 Deep Archive storage systems, being the S3 Glacier part of this. There's usually a customer-provided S3 orchestration layer on top of this, whether that's Ceph, IBM Defender, Cohesity, or any products like this. They're going to have usually an S3 layer that's already in there. We know that Weka is a common one. We work with a lot of other ISVs as well, which is another call out to you guys, since you guys are developers. I know you're not going to go out and buy one tomorrow, but we do have a developer interlock for this product. We have a hosted prototype that you could access if you want to play around with it. We also have some simulators that we can get available to you. So if anybody wants to try out the system, try it out in your environments to see how it works, the response times or anything else, just let me know. We can get you signed up, and I can let you know what the website is to sign up for that. So with this orchestration software, they can do things like mirroring if they wanted to, right? They could write to different S3 endpoints on each of the Deep Archive systems if they wanted to. They can spread the configuration. They can spread the S3 endpoint over both of these Deep Archive systems themselves if they wanted to as well. So as far as mirroring and scale out goes, while it's not built into the system yet, is possible from the S3 orchestration layer to get all of that as of now. And many of our clients would rather do it at their orchestration layer. The idea behind this is stop putting complexity at the lowest layer that a customer has to deal with. We should put complexity at the lowest layer as far as solving technological issues like you guys do every day. But from a user perspective, what they have to deal with, don't make the user learn 6 different tools. If they already have a tool that they know, like an S3 orchestration layer, let them rely on that to manage their system. Don't have them learn another set of tools. As far as installation and configuration goes, this is just to show you how easy it is to get the system set up. So IBM handles the install. They'll install the tape library, the nodes, they'll cable everything together. In the future, this will all be delivered as a single unit, but as of now, it takes the install team, when they deliver the product, it'll come in 3 boxes. They'll install it for you. Takes about an hour, maybe 2, to get all the cabling done. After that, they will attach to the customer's network. This involves 1 management network and 2 data network cables and 2 power cables. So the data network is the programmatic interface. That's what you would expect through any AWS interface, or any S3 interface rather. That's where you're going to be doing your S3 commands, your put objects, get objects, your restore objects, which we'll talk about in a second. The management network allows you to SSH into the system and access a very finite set of commands and CLI commands so that you could operate the box, and we'll go over what those are as well. There's very little a user needs to do with this system. The only thing they really have to do at configuration time is to set up their user accounts and create their buckets. And even then, they can create the buckets from the S3 interface as well if they want to. So after you create the user accounts, you get programmatic access. You get your S3 access keys and secret keys, and then you could access the system. If you're not familiar with S3 Glacier Flexible Retrieval, it does not act like S3 Standard. S3 Glacier Flexible Retrieval requires you, when you're restoring data, to use a restore object command. That means the data, you can't just do a get object. It'll say, sorry, that data is not accessible because it's down on tape or some low latency or high latency system under the covers. In which case you need to do a restore object. You pull the head command until it becomes ready, at which point you could do the get object and you could read the object from the system. As you can imagine, what's happening inside of our system is, of course, the data is being loaded from the tape into the control nodes up top. We have 50 terabytes of RAID 5 NVMe storage inside of each of those servers. So very fast access times once it reads in there. Plus, when we're writing data, when customers write data, we ensure it's optimized for 2 things. One is restore times in the future, so that we're spreading the data across cartridges in a way that when they need to restore it, we could try to do it in parallel as much as possible. And of course, reliability to ensure that the data is written in a reliable way onto the cartridges themselves. And the last one is we're also trying to write to the cartridges to ensure we use the cartridge capacity in an optimal manner. So depending on how you write your data, how many sectors you leave open, what kind of data you're writing, it determines which cartridge you want to have that data, co-resident on. Customer doesn't have to worry about any of that anymore, right? They used to have to worry about that. Now they don't. Now IBM's going to do that for them. As far as the CLI goes, yes, we have a CLI. No, we don't have a GUI yet. This is fresh. I mean, the paint's still wet on this product. It came out a month and a half ago. So right now it's a CLI. The number of things the user has to do through this, we allow, of course, monitoring. You could check out the capacity and the throughput of the system through the CLI. We've designed that in such a way that it's easily exportable to Prometheus if you so choose. Management, pretty much the only thing you're going to be doing from a management perspective is possibly setting up buckets and configuring user accounts. So access controls. As far as service actions go, we have a set of service actions that if anything goes wrong and you're working with IBM, they could ask you to execute service actions so that you don't interfere with any of your ongoing IOs having to do with your production data. Okay, we could talk about cost as well. So this is, I encourage you to check this against other technologies, all other technologies. So this is total cost of ownership. We really Like everybody else who's presented this week, we like to focus on total cost of ownership, not because it makes us look good, but because this is what customers actually care about. As far as hard drives, you can see from this graph, we're about 6 times cheaper than HDD, than a equivalent HDD installation, as far as total cost of ownership goes. And the graph that you see there on the far right is the cloud installation, but that cloud installation is actually S3 Deep Archive storage class. We're compared against the flexible retrieval, which is 3.6 times more than that right-hand graph. So if we listed it, it would have gone off the chart entirely. So just imagine that it goes up to about the ceiling, or just above the ceiling, as far as the comparison of cost goes. This is where customers, we like to say that the moment you buy one of these, right, it says 500,000 on that. If you go ahead and buy one of these systems, you're effectively saving millions of dollars for every system you purchase, if you already have data that's in archival in one of these other formats. We talk a lot about positioning. There are solutions we have at IBM to give you full, access to an S3 type interface. There's IBM Storage Scale plus CES. That's more of a transactional AI storage for data analytics, and that would be the S3 that you would use for there. It's fully featured, so if you're using Scale, you can have tiered storage, you can have full featured implementation of lifecycle management, and fully automated data durability. So Deep Archive is really designed not to be, like I said, a total solution for your S3, a total tiered solution for your S3 environment. It is made to be specifically the archival tier of your S3 environment. And we're trying to do that to keep users' lives simple. If you want to hear more about this, we have our product page here. There is like I said, you can hit this contact link as well to sign up for our hosted prototype if you want to test out any software to go to it, or if you want to play around with our simulators as well. This is a great way to get in contact with us as well. All right, any other questions now that we're at the end? I know we went through this kind of fast, but I like to get to the points quickly. Excellent. So just to sum up, we're really trying to look at not just what technology improvements we can do. We're IBM. We're not looking for venture capital funding. We're looking to satisfy our users' needs and requirements. When we're satisfying those needs and requirements, it's very important for us to laser focus on design work, and we use enterprise design thinking to do that, to focus on our users' needs and ensure that rather than coming up with new ideas that we think are cool, we're coming up with things that actually solve the problems our customers are having today. All right. Thank you very much, guys. Appreciate your time.